Hi folks, I'm Jerry Ellsworth and I'm making this video for the Science Goddess. If you don't know who she is, you should check out her work. She makes excellent science videos. She wrote to me a week ago and asked if I could point to one of my videos that I felt represented my work the best. I couldn't think of just one, so I decided to make this video where I do a simple science experiment and I'll discuss why I make YouTube videos and the reasons behind them. For my day job, I'm an electrical engineer. But I'm interested in anything science-based. If you name it, I dabble in it. There's 4 motivations that drive me to make videos. And to be completely honest, one of those is attention. I like it. The second is the discussions that come after the videos are posted. Third, I like to demystify things that people think are impossible to do at an amateur level. And finally, some of these experiments are completely amazing no matter how many times you do them. And for me, Electrophorus is one of these. I first saw it. It was presented by Julius Sumner Miller, and I couldn't believe it would work. It's a very simple device. It's a metal plate with an insulating handle. Here I used an old hard drive platter and a plastic vial. Next, you'll need an insulator with an electrostatic charge built up on it. Plastics or styrofoam are great for the insulator. You can build up the electrostatic charge by rubbing wool, silk, or animal fur against the insulator. And we'll need a device to see the effects of the charge. This is called a hailstorm box. It's a plastic cylinder with a paper top and bottom with little styrofoam beads inside that are covered in India ink. The India ink is conductive and will take on a charge. If there's a large enough differential in charge, the styrofoam beads will move back and forth, transferring electrons, equalizing the charge. Another device we'll use to detect the voltage is a neon tube. When the voltage gets high enough, the gas will ionize and electrons will flow through. We'll see an orange glow. The last 2 devices relied on electrons moving to detect the presence of a charge. Sometimes we'll want to detect the charge without changing the charge. So I put together a circuit which is a passive circuit that can detect the charge by using a JFET, which is a very sensitive transistor, and an LED and a 9-volt battery. The gate of the transistor is allowed to float and can be influenced by a nearby charge. Sometimes you'll want to pre-charge the gate by touching it. It all depends on the charge you want to detect. The entire circuit's placed inside of a copper tube which is grounded to the negative terminal of the battery, and the gate's pointed outwards. This makes it directional. I want to take a break here and just talk about production values. As you can see, this is about the extent of my production values. It's usually scraps of paper with hastily drawn schematics. Maybe I'll have a transparency overlay that I can slide back and forth, but that's about it, and that's the way I prefer it. What I'm trying to represent here is a side view of the metal disc and its handle, and the insulator. The black circles represent the atoms, and the red squiggles represent the electron cloud. As you can see on the insulator that it's missing some electrons. I did this by rubbing Darlington the cat against it. I need to note that this process also works if the insulator has extra electrons. Just polarities through the whole system will be reversed. When the metal's brought close to the insulator, the electrons in the metal will move towards the insulator to try to fill those vacancies. Even though the metal and the insulator are very close, the electrons can't fill those vacancies. This is called induction, and now the top of the metal will have the same charge as the insulator. If you touch the top, you can supply electrons which will fill those vacancies and neutralize the charge. This is called conduction. If you pull the insulator away, it'll retain its charge, but the metal disc will have gained electrons and will have a negative charge. Okay, we're 4 minutes into this video and we haven't seen anything cool yet. Let's see this in action. Metal disc on the insulator, touch the top, put it on the hailstorm box. Look at those styrofoam beads go. There's so much potential there, it's making them defy gravity. When you touch the top when it's on the insulator, you feel a little bit of a zap, but when you separate the charge and then you touch the metal disc away from the insulator, you really feel it. For the next experiment, we're going to make a very, very primitive Leyden jar. It's just a plastic cup, some aluminum foil, aluminum on the inside, aluminum on the outside. That's it. Just make sure the inside and the outside don't touch. Another name for this is a capacitor, and we can transfer a charge into it. So I'm transferring a charge into the center conductor, and behind it is our apparatus for detecting a charge. So if I hold it up there, I can see that there's a charge, see the lights going out. Now I can charge it up again, and now I have a neon bulb hooked up to a lead, so we can test to see if current will flow between the outer electrode and the inner electrode. And this will prove that we have a Leyden jar effect. Okay, I'll charge it up one more time, and this is absolutely amazing what we can do next. We can take the Leyden jar and dismantle it, of course using insulating pliers, touch every piece of it, and then put it back together and still have a charge. Moving the capacitor detector circuit will give you a clue of what's going on. Now that everything's thoroughly touched, let's put it back together. This is so cool. If you'd like to reach me or Darlington, my email is scorched.chips@gmail.com. Hi, Darlington.